Hi, in this video we are going to work on arithmetic series. So basically, if you add the terms of an arithmetic sequence, it turns out to be an arithmetic series, right? So let's look at an example and get the formulas for calculating the sums in arithmetic series. Prove that the first 100 positive integers add up to 5050. Now, I have to mention that this method was found by the famous mathematician Gauss when he was in elementary school. Well, the story is that his teacher was not feeling like teaching that day, and he said, just add the numbers from 1 to 100 to the class so that he could get some free time. But what happens is in 2 or 3 minutes time, Gauss just went to the teacher showing his result, which is correct, and the teacher was furious. He took Gauss to the principal and Gauss got into trouble. But anyway, we are going to use the same method to find the sum of the first 100 positive integers. Here's how it goes. So let's have the series written from 1 to 100 in addition, certainly not all of them, and then we are going to have the same series, the same sum written backwards. So it's going to be 100 plus 99 plus 98 plus and so on. So it's going to be 3 plus 2 plus 1. And then what Gauss did was to add these vertically so that he would end up with 101. 2 plus 99 is also 101, plus 3 plus 98, 101, and so on. So he gets 101s in all this sum. Now, how many 101s are there? The thing is, just because I have 100 numbers here, it must be 100 101s. So basically what we can do is to say that this sum, 101 plus 101 plus 101 plus and so on, is equal to the product of 100 times 101. Now the problem is I have two of the same series added here when I write 100 times 101. So I must divide it by 2. So you end up, when you calculate, that this is going to be 5050. Now, let's look at this sum a little bit closer. First of all, notice that we get 101s in each vertical sum, right? So this is basically the first term and the last term added. So remember from the previous video that the first term is A, and let's say this is the last term, L, right? So I can write A plus L for 101 here, all right? And then look at here, it's 100 divided by 2. 100 here is the number of terms, so it's n, right? N divided by 2. Why do we divide by 2? Because we have two series. We have to divide by 2 to find the actual sum of one of those series. So it must be then n divided by 2. So this is the formula for the sum of first n terms in a series, in an arithmetic series, all right? Of course, you can use this formula only when you know the first term and the last term. Now, generally we sort of know the first term, but we may not know the last term. So if we don't know the last term, remember how to write down the nth term. So we use that formula. So it's un equals a plus n minus 1 times d, where a is the first term and d is the common difference, remember. So if instead of L I write this, then my formula will become, let me write here, as n equals, I have n over 2, I have the a, and then I'm going to write this one down, so it's plus a plus n minus 1 times d, where I can simplify and say that it's going to be 2a here, right? Now, I think you now remember this formula from IGCSE, right? The sum of the first n terms could be given by this formula. Or, if you have the last term, then you can also use this formula. It is the same. Now, let's see some examples. Given the arithmetic series 4 plus 9 plus 14 and so on, part A says find the sum of the first 35 terms, and part B says find the least number of terms required to have the sum exceed 2000. Alright, let's start with part A. Now, it says to find the sum of first 35 terms. The problem is we don't know the last term, right? So we have to use this formula. And all we need is to figure out what the first term and the common difference is. We already know n is 35, right? So apparently the first term is 4 and the common difference is 5. So let's substitute these numbers into the formula. So it's going to be S35, right? The sum of the first 35 terms. It's going to be 35 divided by 2. We have 2 times 4 plus 35 minus 1 times 5. Now, this is the substitution step. As you know, it's very important to write this down. So if we calculate, we find that the first 35 terms add up to 3,115. Now, keep in mind that you have to write the substitution step, which is very important, but you can skip some or even all of the steps, and after this, write down directly the answer. Now let's go with part B. So we are looking for the number n, all right, which is going to be the least number possible so that the sum will exceed the given number, which is 2000. So this must be bigger than 2000, right? So I substituted the first term, which is 4, and then the common difference, which is 5. Right, now I'm going to manipulate the left-hand side, try to simplify it, and if I consider this quadratic inequality as an equation, I will get n to be 27.99 after 2 decimal places, and minus 28.59. Obviously, I can't pick the negative number, right, because n must be positive, and I should use this number to estimate that n must be 28. Now, if you try this in the calculation of the first 28 terms in sum, you will get 2002 as the sum, which is slightly bigger than 2000. So this is how we can check our work. Now, certainly you should remember how you find the nth term. n equals the first term plus n minus 1 times d. So this is the formula that you may need to solve the problems regarding arithmetic series, right? But pretty much you will be needing the first term and the common difference and the sum of the first n terms, so we denote it as S sub n, right? You need the formula, you need all these three to be able to solve the problems. The question types seem different, but if you stick to these formulas, you'll be able to solve any problems eventually. Thanks for watching.